We're given a series of capacitors in a circuit and a voltage difference across the capacitor configuration. And they're asking us to find the total energy stored in the system of capacitors and then the energy stored in just one of the capacitors. So what you want to do is start breaking these down. Basically, we know the voltage across the whole system, across AB. And if we knew the capacitance, we could find the energy stored, because we know that the energy stored is 1/2 CV squared, and because Q equals CV, we can say that's 1/2 QV, or we can say that's Q squared over 2C. Those are all equivalent because Q is equal to CV. Okay, so we're going to start out by looking at these two capacitors in the top part of this configuration. They are in series, so let's put those together. Here's A, got our original two capacitors, and we want to combine these two. This was our 3.5, this was our 4.8, that's our 8.6, and I'm going to call that C1. And those are in series, so for capacitors 1 over C1 is equal to 1 over 6.2 plus 1 over 11.8. They're all in microfarads, and I get C1 is 4.06 microfarads. Now I have two capacitors in parallel, and I want to combine those two. So what I want to get is this. I want to get I've got my 8.6 microfarad capacitor, I've got my 4.8 microfarad capacitor, and I've got C2 over here, where that's the combination of C1 and the 3.5. So those two capacitors are in parallel, so we add them up. We say C2 is C1 plus 3.5. .56 microfarads. And now I have three capacitors in series. So what I'm looking for is A, B, where I'm calling this C3 now, and 1 over C3 is 1 over 8.6 plus 1 over 4.8 plus 1 over 7.56, and I get C3 is 2.19 microfarads. So I know my equivalent capacitance is 2.19 microfarads. I know my voltage difference across A and B is 12 volts, and so the energy stored is 1/2 CV squared is 1/2 2.19 times 10 to the minus 6 farads times 12 volts squared, and I got 1.58 times 10 to the minus 4 joules. So that's the total energy stored in this system of capacitors. Now if we go back, they want to know how much energy is stored in just the 4.8 microfarad capacitor. So I'm going to jump ahead a couple of steps and look at this configuration right here. We've got our 4.8 microfarad capacitor in series with two others. So in series, we know that the charge stored on the first capacitor, that's this one, the 8.6, charge on the 8.6 has to equal the charge on the 4.8, which has to equal the charge on the 7.56 microfarad capacitor. The charge on every one of these capacitors has to be the same because they're in series, and that has to equal Q total. So I can find Q total because I know C total is 2.19 microfarads, and I know the voltage across that whole thing. So what I say is that the energy stored in the 4.8 microfarad capacitor is the charge on that capacitor squared over 2 times its capacitance. And so we get 26.3 times 10 to the minus 6 squared all over 2 times 4.8 times 10 to the minus 6, and I get my energy stored as 7.19 times 10 to the minus 5 joules. That's the same thing as 71.9 microjoules. This number here, the 26.3 microcoulombs, came from the charge, the total charge, where we said Q total is equal to the total capacitance times the total voltage, and so that was 2.19 times 10 to the minus 6 times 12.